Okay, this recording is part 2 of our expressions and equations review. In the last video we left off with assigning, these problems as homework. So we're going to go over these problems, showing the answers, going over any questions that you might have, including these stories, and then we're going to move on to the next self-assessment and the types of questions that we're going to see over there. Okay, so only continue on in the recording if you're ready to see the answers to check your work. Make sure you've solved each of these first. Number 1, students in class are also checking their answer, x equals 5. Number 2, x is equal to 2. Number 3, x is equal to 17/3. Number 4, x is equal to -4. Number 5, x is equal to, I'll have to write it down here, 3.5 or 7/2. And number 6, x is equal to 2. Based on those answers, are there any that you need to see done because you have made some mistakes or you're just not sure what happened? Any questions on any of those? Yes, Brock. Number 3. Okay. So remember, on all of these, we need to simplify first. So when I'm simplifying, I'm looking at the grouping symbols and knowing that the grouping symbols are there because we are distributing. We're multiplying across those grouping symbols. So I have 2 groups of x, which is 2x, and 2 groups of 3, which is 6. But we also have this plus 4x, and all of that's equal to 40. So one simplifying step, we're still not quite done. We need to continue simplifying. I now have like terms that I need to combine. So I have 2x tiles here, 4x tiles here. 2x and 4x combine to be 6x tiles plus 6, which is equal to 40. Have you found your mistake so far, Brock? Everything's good so far? Okay. I'm going to undo adding 6 by subtracting 6. Balance it, same thing on the other side. And then I end up with 6x, which is equal to 40 minus 6 is 34. We now divide each side by 6, and 34 divided by 6 simplifies to 17/3. Did you find your mistake at some point, Brock? Okay. I'm betting it was this. You said, I'm just guessing, 40 minus 6 is 36. Is that what you did? No? Okay. So just not being careful with your symbols up here with the operations. Okay. Any others that you need to see done? Any others that we have questions on? Yes, Luke. Number 4. Okay, this is like having 2 groups of 2x, but 2 groups of 2x, which is then the opposite of that. So the opposite of 2 groups of 2x, or you can think of it as -2 times 2x, that's going to be -4x. And same thing, 2 groups of 3 is 6, but it's the opposite of those 2 groups of 3. You can also think of it as -2 times 3, which is a -6. That's not all. Just like in the last one, we still have to bring down that plus 3x that's at the end. So after I do those grouping symbols, we bring everything else down, and now we can combine like terms. I have 4 negative x's, and I have 3 positive x's. So when I combine those, 4 negatives and 3 positives, it is going to leave me with 1 single negative x tile, and it is negative. Bring down that plus a -6. No changes there, we just combined our x tiles, and it's equal to a -2. We have to be careful on these solving steps here, especially if I keep this as adding a negative. Adding a negative, remember, the whole thing is we're trying to zero out these -6. So the way I'm going to zero out having -6 unit tiles is if I have 6 positives. That's going to zero out, and we balance it by doing the same thing over here. Careful, look at what we have left. After zeroing out that -6, I still have a -x, which is equal to -2 plus 6, and -2 plus 6 simplifies to 4. This says negative x equals 4. It doesn't say x equals 4. It says negative x equals 4, which means x technically still isn't alone if it's still negative. Now, when we did this with our algebra tiles, and it's been a long time since we've done it, but when we did this with our algebra tiles, we would draw it out and we would say a negative x is equal to these 4 unit tiles. We realize we don't really want to deal with that negative x tile. So if I am going to change this negative x tile to a positive x tile by just kind of flipping it over to its positive version, now I know that it's a positive x, but whatever I do to one side, we still have to do the other side, which means all of these are also going to need to be flipped over to their other side, their opposite side, and those all are going to be negatives. So one x tile is equal to 4 negative tiles. That's the way that we did it many moons ago. What is that going to look like if I'm doing this algebraically? We've also talked about this before. How many x's do I have? 1. But it's not just 1, it's negative 1. How are you going to undo multiplying by a negative 1? We divide by a negative 1. A negative 1 divided by a negative 1 is going to divide out, leaving me with x is equal to 4 divided by a negative 1 is a negative 4. I'm betting that the mistake was on how we handled that negative x. Is that a correct assumption? And do you see why now we need to be a little bit careful with that? Okay. Good questions to ask. Are there any other questions? 1, 2, 5, or 6, anybody? Feel good about those ones? Okay. I am going to go over number 2 and number 5, just because I have a feeling that many students did make mistakes on those ones. So let's go over number 2 and number 5. What I see is negative 4x and positive x. So when I simplify this one, I'm going to be combining these terms, and 4 negatives and a positive are going to equal negative 3x. Folks, we should probably be focused on doing our problems instead of playing with our hair. Just saying. Minus 6 is equal to negative 12. I'm going to undo subtracting 6 by adding 6. Balance it, do the same thing to the other side. And I end up with negative 3x is equal to negative 12 plus 6, which is negative 6. From here, I'm going to divide each side by a negative 3 to keep it balanced, and I end up with x is equal to negative 6 divided by negative 3 is a positive 2. Math practice 6, attend to precision, don't lose those negatives. Speaking of negatives, that's also why I'm going to be doing number 5. We need to be careful with how we handle this. On your last test that had a problem very, very much like this, there were a lot of mistakes because we're not handling this okay. We're subtracting the entire group of parentheses. So the best thing to do is to change that subtraction to adding a negative. And now with that step, it makes it a little bit easier to see that what we're doing is we have a negative, or the opposite of k, and we have the opposite of 6. So I'm distributing that negative across the parentheses. No different than distributing this negative 2 across the parentheses. It's just now there's not a number attached, it's just that negative. So the opposite of k plus the opposite of 6. That's the one simplifying step that I took. Everything else comes down. I didn't do anything with that 7k. Didn't do anything with this 2k. And now all of that is equal to 22. So now when I combine like terms, I can see I have 7k here. I have 2 more k here. That's 9k. And then I've got a negative k here. That gets that down to 8k. All of those combined is 8k. I'm realizing this is actually not like the one on your last test. This is the one from your last test. I undo the negative 6 with positive 6, balancing it on the other side. And that leaves me now with 8k is equal to 28. I'm going to undo the multiplying by 8 by dividing by 8. Doing the same thing to both sides, and now I have k is equal to, as a fraction, 7/2. This one is a nice decimal, so 3.5 is fine. Please, everyone in class who has kind of moved on to doing their own thing, please stop and discuss with your groups. Why did I give you the answer here as 17/3 and I gave you the answer here as 3.5? Discuss why I might have done that. All right. And now back to me. 17/3 is not a nice decimal because it's 5 and 6 repeating. And since it's not a nice decimal, and most of you guys forget to include that the 6 is repeating with that overbar, it is just a much safer bet to just leave it as a fraction. Here, we can leave it as a fraction. There's nothing wrong with that. But a decimal is appropriate here as well. If you struggled with number 1 and number 6, the answer key is in Canvas. The answer key includes all of the work shown, all of the baby steps. So if you're struggling with those one, you can check the answer key there. Let's go over 10 and then 11. 10. Any ideas on how we should get started here? Okay, so we should probably really be studying this. And we should probably, with only 2 hands in the room, we should probably on that self-assessment rate ourselves pretty low. When faced with the word problem similar to those in this chapter, I am having a difficult time seeing the pieces of an equation, how they relate to the story. So you should probably rate yourself here. The 3 who your hands are up, let's see how you did. Seth, get me started. What are your thoughts? Yes. So you took the time to do this, which I said from the very beginning, especially last time for our last test, this is the key to success. Tell what Nicole is, tell what Sarah has, and tell what Belle has. We're going to pause and write these little expressions to represent each individual before we try and connect all those pieces. Go ahead. Do you want to continue on with what you wrote down there? Sure, if you're ready. $5S. Why S? Very good. Nicole saves 5 times as much as Sarah. So, Nicole is 5S. What does that make Sarah then? You could do that, B plus 20, but now look at how many variables I have. So what you're saying is all correct, but have we really solved very many equations at all with multiple variables? And so, although this is correct, it's not going to be super helpful, so I want to make an adjustment. Go back to this sentence. Nicole saves 5 times as much as Sarah. 5S. What does that S represent? Sarah, exactly. So what should I put for Sarah? S. No, Nicole is 5S. Because Nicole is 5 times as much as Sarah, which makes Sarah just S. That's why you chose S, isn't it, Seth? You chose S because it represented what Sarah had. So how do we relate that to Belle? That's where we need to make a little bit of an adjustment because I know why you did the Belle or B plus 20, but now we need to think about this a little bit differently. What is that going to look like, Danielle? Exactly. If Sarah saves $20 more than Belle, then Belle is going to be $20 less than Sarah. So now I have related all of these 3 amounts together by using that same variable instead of trying to use different variables. Nicole is 5S, 5 times what Sarah has. Sarah is just what Sarah has, but then we can relate what Belle has to what Sarah has by going less by 20. This is really important to your success. Let's keep on reading. I'm going to move on from Seth, someone else who thinks that they know what to do next. Okay, Sam. We do have to set up the equation. Good. What is that going to look like? Good. Because we're saying what Nicole has, what Sarah has, what Belle has. We're adding all of that together. Okay. So close. And this is what was so funny about the test version of this that I gave you. It was bolded, italicized, and underlined, and most of you still ignored it. At the end of the summer, which is 3 months. Because read the problem. Nicole and her sisters are saving money over the summer. Each month, Nicole saves 5S. And each month, Sarah saves S. And each month, Belle saves S minus 20. So, what changes do I need to make here, Maverick? Multiply it all by 3. So I'm going to multiply everything by 3. Exactly right. That's one way to do it. Part of the simplifying is maybe a better way to do it. 3 of 5S and 3 of S and 3 of S minus 20. That is what it takes to get to that 2040. Okay. And then we can start really breaking it down. 3 groups of 5S is 15S. And 3 groups of S is 3S. And 3 groups of S is another 3S. And 3 groups of minus 20 is minus 60. All of that equal to 2040. And then we can start combining our like terms. Now that I have no more parentheses, I can combine those like terms. 15S and 3S and 3 more S means I have a total of 21S minus 60 is equal to 2040. Nice simple equation now. Now that it's set up, the solving part is easy. We're going to add 60 to each side. That leaves me with 21S, which is equal to 2040 plus 60 is 2100. I'm out of space. 21S is equal to 2100. Divide each side by 21. And that's how I get S is equal to 100. Solving the equation isn't enough. Now we need to go back. How much does Nicole save? Nicole is 5 times S, so that's going to be $500 over the whole summer. Sarah, or not over the whole summer, each month. Sarah saves 100. And Belle is 100 minus 20, so that's going to be 80. I do need to point out this is a mistake, and I apologize that I did not catch it. It should not be how much does each person save per week. It should be how much does each person save per month. Otherwise, we then have to divide that by the number of weeks, and that gets to be messy. So I apologize for that mistake and that I did not catch that earlier. Okay, so rate yourself appropriately on that rubric. Were you able to do that on your own? Some of you, maybe. Some of you, most of you, no. Learn from that and now finish up number 11 with your groups. Ready, set, go. Number 11 with your group, 60 seconds. Pause the recording until you do that. We're going to go over it in 60 seconds. Jose and Elise go to the fair and spend the same amount of money. Jose rides 5 rides and spends $12 on a BBQ sandwich and corn on the cob. Elise rides 7 rides and spends $4 on cotton candy. Write and solve an equation to determine the cost of a ride at the fair. How do I set this up? Maverick, thank you for helping us out. Yes, so again, the key to success here is setting up this information. Jose is, what did you say? Thank you. I was hoping Maverick would repeat his answer, but he got distracted by the fact that he didn't say that name right. Yeah, Jose. Elise, go ahead and tell me that one, Maverick. Elise, what? Yeah, 7x plus 4. With the x representing the number of rides that they've ridden. Okay, doing this is great. What do I do with that information now? Let's move on to someone else. Same students, citizenship adjusted. Sam. Whoa, whoa, whoa. We don't even have an equation though. Nope, we haven't made it that far. So what's the equation? Exactly, because they spend the same amount of money. So this represents how much money Jose spent. This is how much money Elise spent. We set them equal to each other because they spent the same amount. So it's equal, it's balanced, it's the same. Jaden, what's my first solving step? Well, I can't zero out both of them. Okay, so I want to get rid of this 5x, going to zero it out, and in the process of that, yes, we balance it, take away 5x there too. Zeroes out, and now I have 12 is equal to 7x minus 5x is 2x plus 4. 2 more solving steps. Tell me one of them. Porter. Good. Great explanation. We're zeroing this out, so we subtract 4, balance it, do the same thing to the other side. And 12 minus 4 is 8. 8 is equal to 2x. Final solving step, divide each side by 2. I'm not going to call on anyone for the easy one. X is equal to 4. So what does that mean? We found x equals 4. Put it back into the context. What does that mean for the story? Danielle?
It's $4 per ride.
Yes, $4 per ride. So again, on this set of problems, if you read the directions, it says before solving each equation, examine the structure of the equation and determine whether it will have one, no, or infinite solutions. If you can just look at the structure without taking any solving steps and figure out if it's one solution, infinite, or no solutions, then you can probably rate yourself high on this end. Nope, I'm sorry. Part 2 is where it would be. Can you see if it's one, infinite, or none just by looking at the structure? That's the second one. Rate yourself there. Then after you do that, let's solve it. Can you solve them correctly? That would be how you rate yourself on this row here. So students have also worked ahead and gotten a really good head start here. So I'm going to have them start sharing out some of the answers. Number 1, one solution, infinite, or no solutions.
One solution minus 2.
Tage, how do you know that it's one solution?
Because when you look at the g's and stuff, they're not like the same number.
Yep. Yeah, we have 8g here. We have 4g here. So there's different amounts. They're not going to zero out, so I know it's going to be one solution. 2, one solution, no solution, infinite solutions. Charlie, how do you know? Good. Again, we don't have to actually officially solve it. We know that when I have 1x here and 1x here, when I try and take away this x, it's going to zero out this one too. It's going to leave me with a lie. 1 is not going to be equal to negative 2. So that would be no solution. And number 3. Jamie, how do you know? Good. They have a different number of x's. And again, we might have to take a simplifying step first. We can see negative 2x plus 4x is going to be negative 2x. And it's equal to, on the other side, negative 3x. So again, one step. I haven't completely solved it, but now I've done enough that I can see different amounts of x's on each side, so one solution. And of course, you'll have to solve them. But I just want to focus on that first part. Looking at the structure, how can we tell if it's infinite, one, or none? Let's go on to number 4. I've seen these hands before. Gabe, how do you know? Yep. So 2a, and then when I take the simplifying step, there's going to be 3a. I don't even need to finish distributing right now to recognize 2a and 3a are different. That's going to be one solution. This one we've got to take a few more steps. Maybe we don't see it right away, maybe we do. What do you know about this one? Infinite, one, or none? Brock? This is, again, one solution. A couple solving steps maybe. 2x, and then we have minus 2. Bring down that negative 5x, and comparing it to negative 12 plus 2x. I would have to combine these like terms. Negative 5x plus 2x is going to be negative 3x, and now I can confirm what Brock said. We have different number of x's. 2 x's here, 3 negative x's here, different amounts, so it's going to lead to one solution when I finish solving. Last one that we're going to go over on the video. 6. Infinite, none, or 1. Daxton, how do you know? Yes, this one right here. So the subtraction, okay? Okay, so 5 minus 2a, so minus 2a, and then minus 3 or minus a negative 3, however we want to talk about that, or the opposite of subtracting 3 is going to be add 3. Good. And with that, what do we now see? Without having to do any other steps. Don't they look identical on each side? Yeah, so infinite solutions. Not only do they have the same number of a's, negative 2a and negative 2a, everything else is also the same. All right, we are just about out of time. There is one that I want to talk about. All of these are for sure part of the homework as you're studying. So this back page is all part of it. However, all of this back page is not related to the rubric. Okay? These are just additional practice problems. Please pay attention to number 11. You all struggled pretty hard on that one with that quick pull, right? So let's make sure we can recover from that. If they have the same perimeter, what does that mean? It's the same, it's equal. And it also means, well, what is perimeter? Perimeter is the fence that we build around it. X plus 2, x plus 3, x plus 3, all of that added together. And it's the border. It's all the fence going around the outside. So this is going to be x plus 2 plus x plus another x plus 2 plus another x. In other words, x plus 2 plus x plus 3 plus x plus 3. That's the triangle. Equal to, I'm lazy. So when I'm doing the right-hand side, I'm going to be like, hey, there's 2 groups of x plus 2. See that? Here and here. And there's 2 groups of x. So I wrote that expression a little bit more simply. Can you solve that equation? Yes, of course you can. Find that value of x. And the last one that I would like to address on the video, number 16. A common mistake has been made. I'm going to tell you right now, 2 mistakes have been made. Go through that process, find the mistakes, explain those mistakes. All of the answers are going to be in Canvas in multiple places. So it should be pretty easy to find. Go to the review, click on where it says click here to check your answers. Check those answers tonight so that you're prepared for that test tomorrow. Fits. Good. You can check it against the answer key. We're out of time, so we don't have time to discuss it. That's it for this video. Thanks for watching.